Good morning, students. Now in this class we are going to discuss about lexical analysis phase. Okay, as all of you know that totally we have 6 phases of compiler. In previous class we have studied about the different phases of compiler, that is lexical analysis, syntax analysis, semantic analysis, intermediate code generation, and next one is code optimization, code generation. Among those all the phases, the first phase details we are going to talk now. That is the lexical analysis phase. Here, first one is what is the role of a lexical analyzer? As all of you know that, first of all, a lexical analyzer read the source program character by character. We can call it as a role of lexical analyzer or lexical analyzer function also. In this second part, it is the first and second part. In this part, we are going to talk about the along with role of lexical analyzer. We are going to know lexical analysis versus syntax analysis, and next one is what are the attributes of tokens. Next, what is a input buffering, and what are the various specifications of tokens, and at the same time recognition of tokens, and finally transition diagram. All those things we are going to learn. Here, basically, if you see this diagram, the lexical analyzer read input characters in the source program, group them into lexemes, and produce a sequence of tokens as output. Okay, that is for the lexical analyzer phase, we are going to give the source program as input, and it will produce the tokens as output. As all of you know that a token is a variable, or it is a identifier, or it is a constant, or it may be a keyword or any operator. Okay. At the same time, output of lexical analyzer. Output means it is a sequence of tokens sent to the parser for syntax analysis. Here, parser means we are going to send the tokens for syntax analysis phase. Lexical analyzer interact with the symbol table to collect information about tokens before passing to parser. Okay, here we have symbol table also. Lexical analysis phase, at the same time parser, both are interacting with the symbol table. Interaction between lexical analyzer and a parser, that is syntax analysis. Parser means we can say syntax analysis, next phase of lexical. That is implemented by method called getNextToken issued by parser. Okay, here we are going to use one method called that is getNextToken. And next one is some lexical analyzers do additional tasks like stripping out comments and white spaces. That means blank space and tab spaces. A lexical analyzer provide error messages with line numbers and corresponding column numbers also. And one more thing is another role of lexical analyzer is it will count line number of source program. So for example, in source program we have some 10 lines. It will count, okay, which line we are going to convert it as a token like this. And next one is it is divided into two processes, one for deleting comments and white spaces, and another one is for producing sequence of tokens. Okay. Next, why we need to separate a lexical analyzer from syntax analyzer. That means why we are going to differentiate these two. First one is we have several reasons. First reason is to make the design of compiler is simple. Okay, at the same time, second one is to improve the efficiency of compiler. We are going to separate the lexical analyzer with syntax analyzer. And next one is to enhance computer portability. Okay, all these are the three reasons why we are going to differentiate the lexical analysis phase from syntax analysis phase. Okay, so this is the role of the lexical analyzer. Okay, this is the representation of the diagram of role of lexical analyzer. So next topic is lexical analysis versus parsing, or we can say syntax analysis. Here parsing is nothing but we can call it as a syntax analysis, second phase. Okay, there are number of reasons for which lexical analyzer is separated from parsing. That is just now we said na. First one is simplicity of design. Second one is compiler efficiency is improved. Next one is compiler portability. Whereas if you take first one, simplicity of design, by separating lexical and syntax analysis, we can simply we are going to simplify at least one of these phases. At the same time, we can design new language by separating these two phases will give better idea about complete design. And the next second one is compiler efficiency is improved. How? Means a separate lexical analyzer allows us to apply the special technique for lexical tasks, not parsing. In addition, we provide a special buffering technique added to lexical phase to speed up the compiler process. Next one is portability, that is compiler portability. By separating lexical and syntax phases, input device specific particular can be restricted to lexical analyzer. Because of the separating lexical and syntax phases, one phase does not disrupt the work of other phase. Okay, these are the three reasons why we should separate them. Okay, next coming to some of the definitions of lexeme, pattern, and token. Okay, see these are the some definitions where we are going to use the in the lexical analysis phase. Lexeme, simply we can say lexeme is a sequence of characters in source program. We can say lexeme, for example, int I, or we can say num, or t1 is one variable. Okay, like this, all these are the sequence of characters. We can say lexeme. So next one is a pattern. So what is a pattern? Pattern, simply we can say set of rules that describes token. Pattern is nothing but a set of rules that describes the token. For example, L of L by D, or we can say L of L or D. Letter L is nothing but a letter, or D means a digit. Okay, like no, what is a token? Token is nothing but it describes the category of input string. We can say examples of tokens are identifier is a token, keyword is a token, or operator is a token, special symbol is a token, constant is a token. All are the different examples of tokens. So next one is attributes of tokens. Okay, attributes of tokens. For example, here, whenever more than one lexeme can match pattern, lexical analyzer provide additional information in the form of attribute about particular lexeme that matched. At the same time, attribute value for identifiers is pointed to symbol table entry for identifiers. For example, here token name and associated attribute value for E equal to M into C into 2. That is M into C equal to E equal to M into C star star 2. Okay, so here whereas coming to attribution of tokens, we have token name along with attribute value. See here, for E we have ID, that is comma ID comma 1. 1 is the attribute value equal to, okay, then ID comma 2. Okay, what is meant by ID? This ID is for M, that is token name, and 2 is for attribute value, second attribute value. Okay, star, again ID comma 3, this ID is for C. Okay, again 3 means it is a attribute value for C. Here 1 2 3 like this. Okay, 2 stars, star star, again 2 is a number, so num comma, so this attribute value is 2. Okay, so simply it is a ID equal to ID into ID into ID. Okay, so here first ID is for E, again equal to ID is for M, again star, ID is for C, again 2 stars, star star, again ID is for 2. Okay, so what are the, how we are going to represent the attribute token is we are going to mention the token name along with attribute value. Okay, So this is the attributes of a token. So next one is the input buffering. Okay. So what is the input buffering? Generally, input buffering is a special technique developed to reduce amount of time taken to process large characters during compilation. Whenever we have a large number of characters, then only we are going to use this input buffering technique. In input buffering scheme, lexical analyzer scans data from left to right one character at a time. So this is the main point. In this input buffering, what we are going to see is the lexical analyzer. It is going to be scan the data from left to right one character at a time. In this scheme, buffers are used and each buffer size is of n. If less the number of characters in input file than n, then we use special character, that is EOF, that is end of file, to end of source file. If uses two pointers, we are going to use two pointers to keep track of the portion of the input. Okay, first one is pointer lexeme begin. Okay, lexeme begin mark the beginning of the current lexeme. Okay, this is one pointer. Again, second one is pointer forward. Forward begin. These two are the two portions. Okay, first one is pointer lexeme begin. Next one is pointer forward. What is the purpose of pointer lexeme begin? It marks the beginning of the current lexeme, where the current lexeme was. Again, pointer forward means it scan the forward until a pattern match is found. In this one, there are two methods is used in input buffering also. The first one is one buffer scheme and the second one is two buffer scheme. Whereas coming to one buffer scheme, in this one buffer scheme, only one buffer is used to store input string. Here problem is in this scheme is if a lexeme is very long, then it cross a boundary to scan rest. To scan the rest, we reset the buffer. It will override the starting part of lexeme. To overcome the above problem, two buffer scheme was introduced. Okay, there is a problem with one buffer scheme. Okay, in order to solve that problem, we are going to use the one more technique, that is a two buffer scheme. Okay, here the problem in one buffer scheme is if the lexeme is very long, then it cross boundary to scan rest. We reset the buffer. It will override the starting part of lexeme. Okay, this is the drawback. To overcome the drawback, we are going to use the two buffer scheme. In this two buffer scheme, what will happen is two buffers are used to store input stream. Here, first buffer and the second buffer scanned alternatively. So the problem was solved. While end of the one buffer is reached, other buffer is filled. Once a lexeme is determined, forward is set to character at its right end. After lexeme is recorded as a token in the symbol table, then lexeme begin set to character immediately after lexeme just found. Each lexeme is identified by scanning one character. That character must be moved before matching to pattern. Okay, so these are the one pattern, one buffer, and this are two buffer. Next, one more thing is we are going to use the technique called sentinels. Okay, in the above scheme, we make two tests before reading character. Those are what character is read, check whether it is a lost character in the buffer or not. To overcome the above condition, we use sentinels. Okay, here sentinels are special characters that can't be part of program. It avoids testing of end of buffers. Okay, so the representation of the sentinels is shown here. Okay, equal to m into c into 2. Okay, here we have end of characters. Okay, so it is regarding input buffering. Okay. Then and next one is specifications of tokens. Okay, specifications of token. In this specifications of token, there are majorly three topics we are going to learn. That is strings and language and regular expression. Okay, see, first of all string, and then what is a language, and then what is a regular expression. Here an alphabet or character is a finite set of symbols. What is a string? A string over an alphabet is a finite sequence of symbols drawn from the alphabet. So then what is a language? So language is any countable set of strings over some fixed alphabets. Okay, it is a language. So these are the definitions of brief definitions of string language. Then in language theory, the term sentence and word are often used as synonyms of a string. Okay, whenever we are going to represent the string, we can say sentence or word. These two are the synonyms for representing the string. The length of the string is usually written in mod. Okay, is the modus, that is the number of occurrences of symbol in S. For example, here I am writing one string, that is banana, is a string of length 6, BANANA. The empty string denoted with epsilon is the string of length 0. Epsilon means there is no length. Okay. So again, what are the various operations that we are going to performing on strings? Okay. So the operations are first one is prefix operation, again next one is suffix, again next one is substring. These are the various operations which we are going to performing on the strings. Okay, first one is if prefix of string S is any string obtained by removing 0 or more number of symbols from the end of the string. For example, you have BAN is a prefix of BANANA. Okay, so BAN is a prefix. Again, next one is suffix. Suffix of a string S is any string obtained by removing 0 or more number of symbols from the beginning. For example, NANA in the banana, NANA is the suffix of banana. Okay, it is a suffix. Like no, here a substring, again next to operation is a substring of string S is obtained by deleting any prefix and any suffix from S. See, for example, NAN is a substring of banana. Okay, so here how we are going to get substring? We are going to delete any prefix. Prefix means friend, or suffix means after. Okay, we are going to delete any prefix and any suffix from S. Okay, so here example is from the banana. What is the substring? NAN. Okay, NAN is a substring of banana. So all these are the various operations of strings. Okay, now in this class we have studied about first one is what is the role of lexical analyzer. Next, what are the various, how we are going to differentiate, what is the need of differentiating the lexical analysis versus parsing. Next one is what is a token, what is a lexeme, what is a pattern, and how we are going to represent the attribute, and what is the input buffering. What are the two types of two methods we are going to implement in input buffering, that is one buffer scheme and two buffer scheme, and also along with sentinel buffer scheme. Okay, next one is, next topic is in the specifications of tokens. We are going to talk about the strings. Okay, so in next class we are going to talk about language. What is a language? Then what are the operations performed in the language? Next, what is a regular expression? What is a regular definition? How we are going to recognize the tokens? Next, what is a transition diagram? How we are going to generate the lexical analyzer, that we can call it as a lexical analyzer generator. Then the structure of lexical analyzer generator, and finally design of lexical analyzer generator. Okay, thank you.